this problem is one of the hardest problems for me to explain, but I'm going to try to do my best. So I'm given a string, and I need to find the longest substring without any repeating characters. For example, I have ABC, ABC, BB. Using my eyes, I can just see that ABC is the first longest substring without any repeated characters, and the length is 3. Everything else, yeah, there's nothing longer than 3 to give me a unique substring, no repeated characters. So I understand what my input is. My input is a string, and my output is an integer. Integer represents the length of the longest substring without repeated characters. And as for matching, I guess it would be similar to like maybe the anagram problems, or let's see, anagram problems, or like the word length, like the longest, what's the length of the last word, that kind of problem. So I know I'm gonna need some kind of a map. So I'll be using a dictionary to map my indices of all the characters in the string. Let's see, I'll need to keep track of starting indices. So my start index. What other variables I may need? I need a bunch of containers to hold that start index. Let's see, yeah. So it'll be like my start index, max length, and the map, start length. Yeah, that's all I need for my container. So in my loop, I'll be going forward. I only need one for loop going forward. I'll be solving this in O of n time complexity. So what's my plan? So this might be hard to follow, but bear with me. So the plan is, let's see, I'm going to use this example. PWWKEW. So my plan is, in my loop, I'll be looking at, so my first iteration is going to immediately look at P. Then the length of P is 1. So far, between 0 and 1, my longest string without any repeated characters is 1. So P. My next iteration loop, I'm going to continue looking at the string while keeping my starting location at 0. I'm going to look at P and W. So that's going to be the string of the length of the string is going to be 2 because P and W. That's my second iteration of the loop. While I'm doing this though, I'm keeping track in my dictionary of like, oh, P, first iteration, P is at index 0. This W is at index 1. So in my third iteration of the loop, I'm going to check in the dictionary. Wait, W already exists, so I need to update my starting index. So my starting index now need to start at this W. So like while I was on, let's see, while J is equal to 2, I'm on my third iteration of my loop. It found out that like, oh wait, there was already a W, and the W was at location 1, so I need to update my starting index to be 1 plus 1 to look at this single W here. So that's my third iteration of the loop, and that's my new starting location. So I'm going to look at, and the length is still only 1 here. So far I had a length of 2, and because I found this second W, length goes back down to 1. Oh, alright. Meanwhile, in this loop, my max length container has been finding the maximum length every time. So it found P, max length between 1 and 0 is 1. Then PW, max length between 1 and 2, well, it's 2. Then I found this W. Well, max length between this 1 and this 2 is still 2. So I'm still keeping track of the maximum length so far, and it was PW so far. So my current string length is at the 1. My next iteration, I'm going to look at K. K, update my dictionary. First time I see K, then I'm gonna update my max length, and then there's no update needed because there's PW and then WK. Well, it's still 2. Then my next iteration of loop, I'm gonna see E. E is not in the dictionary, so far so good. WKE, and then it finds the maximum length. Between WKE, the max length of that is 3 compared to the first time I see PW. Well, that's the max length is now 3. I take the maximum between 2 and 3, then it takes the 3. Then I'm going to move on to my last iteration of the loop. It's going to see W. Wait, W already exists, and it existed here. That was my last known index. So I need to move the starting index to where K is. So my current iteration of the loop is at W. My start index is at K. So my new string length is still, string length is 3. And compared to WKE, string length 3, and between KEW is still 3. So, and this is my last iteration loop. So the maximum length here has been 3 because of this WKE, not because of KEW, but because of WKE. And that's essentially how my loop works. I'm always finding the maximum of between the two starting indices and the maximum between the two lengths of compared to the current one and the previous one. So to begin this mapping, I'll call this dictionary last index, and this will be a dictionary. I'll need a starting index container to start at 0. I need my max length container to start at 0. Now I'm going to go to for loop. I'll use J instead of I, just so I don't get confused with I always associate I with indices, so I'm going to use J instead. So between the range of, J for range of the length of the string, of the input string. I'll call input string input underscore string. So now I need to constantly update the starting index. So to do that, I need to check if the characters are already in the dictionary. So input string at the current iteration of J, if it's in the dictionary, in the last index, if it's in last index's dictionary, then I need to update my starting location. So start index is equal to, again, I'm finding the maximum. So the maximum between the current start index and the index of what it was last seen at. So last index at string J, and last index at string J. So if I find this second W, it's going to find this index here, last index is going to be 1, but I need to start at the next one, the second W. I don't want to start at the first W, so I need to add 1 here. So that will be my new starting location once I find a repeated character. And outside of this if statements, I'm constantly updating the max length. And that's going to be the maximum between the current max length and, let's see, at J. So J, minus the start index minus 1. Oh, I mean to say this starting index. So this number, gonna want to find the start index minus 1, the one behind it, then subtract with j. Then I also need to update my last index dictionary. If it finds any repeated characters, it's gonna update the last one. So this will, if I find at this w, so this instead of w at 1, now the last index it will be, at w it will say 2 in this dictionary. So last index of string j is equal to j. And after all this, I just need to return max length. Oop. While constantly finding this one. To explain this minus 1 here, let's look at this second w here. I'm currently at w here, so my starting index is now at here, at 2, and my last known length is at is 2 from the PW. So here, while I'm in my third iteration of the loop, again, third iteration of the loop means I'm at the second W. So right now, max length is at 2 because of the previous PW. And then because I updated my starting index from the dictionary, since I found this second W, so my J's, as I said before, is at 2, and my last known index of this place was at, again, myself, 2. So that's going to be 2 minus, and inside this one, 2 minus 1, which is 1. So I'm going to have j here minus 1 to give me the length of this string w here. So that should be 1. So between the maximum length of pw of 2 and here, between this length, maximum length of this single w here, 1, nothing changes for max length. Max length remains at 2 because of pw. Because, yeah. So this represents the length of the current string, which is 1 at this single w, because I updated my starting index. So, because I didn't want to just say j minus start index plus 1, well, plus 1, because this was, it would be harder to explain if I just have like this plus 1 as opposed to if I have it minus 1 and I put in parentheses here. And this logistically makes more sense in my head. But but in the end, after you simplify, is that becomes plus 1. And that was my best explanation of this number here. And that's, yeah. Otherwise, I would put this plus 1 and I would have no explanation, no good explanation to explain why there's a plus 1. So that was my best attempt explaining that this is not a magic number, as my professor would say. And that is all.